Okay, last time we talked about MapReduce and gave the abstraction and went through some examples. And we ended up on this slide, which is maybe the first time we've seen pseudocode or any kind of code that actually implements these map and reduce functions. And so I asked you to sort of take a look at this. Actually, at the end of the last segment, there are a couple of changes, mistakes that I've fixed in this slide. So you can compare the two and see if you can figure out what the mistakes are and why I changed them. Okay, so let's walk through this. So what does this code do? Well, as I sort of gave away last time, this implements this word count application that we went through schematically, with cartoons, and this is the pseudocode that actually implements that, or an example of pseudocode that could implement that. You can't execute this code since it is just pseudocode. So what are we looking at here? Well, the input, as we said, the data model of MapReduce is key value pairs, and so the input is going to be a big set of key value pairs, and the map function is going to operate on one of these key value pairs. And in this case, the key is the document name, and the value is the document contents. So it could be a big string, right? It maybe comes from a PDF file or a text file or a web page or whatever. Okay, and so this code is pretty simple. It says, well, for each word W in the input value, so this sort of assumes that somehow you can iterate over all the words in the input value in the text of the document without really specifying how. Then emit a key value pair where the key is this first element, which is the word, and the value is the number 1. Okay. Then the magic shuffle phase takes over and groups all the key value pairs that share the same key into a single group. And so all the occurrences of a particular word will show up as a group. And how that group is represented is as a key along with what we've called here an iterator over the intermediate values. And if you're not familiar with the term iterator, you can think of this as just a collection of values. Okay, so as an example here, if you have the word, the map function will produce pairs like this. Every time it sees the word history in any document, it'll produce this. And then finally, on the reduce side, you'll have the word history here and a sequence of number 1s. Okay, and so what does this code do? Well, it initializes a final result to 0, and then it says for each value in this list of intermediate values, add that value to the result. And so here we just add them all up. And then finally we emit a final key value pair, which is the intermediate key, the word itself, and the final result. And so maybe the output here is, history 25. And we walked through this a couple different times, so I'm hoping this is pretty clear by now. Now, I claim that without changing this reduce function at all, you could make a change to this map function and get a significantly faster algorithm for computing this. So I want you to think for a second about how that might be done. So the thing to look at here is that, oh, goodness, we're emitting a key value pair. Well, I gotta stop resting my hand on this. We're emitting a key value pair once for every occurrence of a particular word. And each one of those key value pairs has to be shuffled across the network and sent to the reducer. So if we see the word history 25 times in a single document, we're going to emit 25 key value pairs for that word, and they're all going to get grouped up by the shuffle phase. But we have access to the entire document here in the map, in this map function. So why not pre-count all the occurrences of those words and produce a different key value pair? Right? Which means the word history appeared 25 times in this particular document I'm processing. And so now, I shouldn't have said 25. Sorry, that's confusing. That's confusing. I didn't mean to make the same number as this. This is, in our previous formulation of this problem, it turned out that we said that the word history had appeared 25 times across all documents, and I shouldn't use the same number up here because that's pretty confusing. So let me change that. So here we say the word history appears 5 times in this particular document, and it appears other times in other documents. Okay, so now we have only one key value pair emerging from this document for the word history as opposed to 5 different ones. And overall, across all the documents, across all the computers being applied to this problem, that's a significant savings. Okay, and then, double check to make sure that you don't have to change this code here, but you hopefully it's clear that you don't, because you're adding the total value into the result. And so here, instead of adding the number 5 times, 25 times, I guess, in the reduce side, you're adding it some number of fewer times, right? You're adding 5 plus 10 plus 3 plus 4 and so on to get 25. Okay, so this loop is evaluated fewer times. Okay, so the reason I want to go through that example is to demonstrate that, there's 2 things. One is to try to think in terms of MapReduce and think about how you can cast a problem as operating on a bunch of chunks, emitting keys to define groups, and then operating on those groups. But also that, you actually have a lot of control over the performance of these algorithms by just modifying the map and reduce functions, right? So even though you aren't working on the system internals, you only have these 2 points of control, you can actually get very different algorithms, very different behavior, and different amounts of intermediate results being created, and so on, just from these two functions. And so you want to get a feel for not just how to express it in MapReduce naively, but also get a feel for how to do things reasonably efficiently. And in fact, this example sort of demonstrates one of the things you're going to be looking for is the bottleneck often, not always, is the amount of data going across the network. And so if you can reduce the amount of output produced by the mappers, especially in terms of number of key value pairs, you'll tend to improve performance. Again, not always. And we'll see some more examples of this. Okay, so I'm going to stop there, and in the next segment we'll go through a variation of this problem that has similar characteristics, but really just to drive home how to design these MapReduce algorithms on slightly variant problems.